Now we're going to flush out the drain line. This is very important because a lot of times each year the majority of calls that we get are things that are related to a clogged drain line. And with the money you'll spend on a service call for us to come out and repair a drain line or flush out a drain line, you could have easily spent that money on a maintenance agreement that would have gotten you the service that I'm performing today twice, plus additional discounts, all for roughly the same cost for me to just come out one time and clean the drain because it backed up and caused a problem. So it's really important that on our maintenances we get these nice and clean. So I'm going to vacuum it out, and while the vacuum's running, I'm going to go inside. I'm going to pour a little bit more of that sanitizer down through the drain and let it flush out through the drain while it's on a vacuum. Not all systems have this, but pretty much every time we install a system, and most systems do have a service port like this. And what this is for exactly for what we're going to do right now. To prevent your drain line from getting clogged up, the homeowner can periodically put maybe a little bit of bleach, dilute it in water. Some people prefer, if you want to go with a green-friendly cleaner, vinegar works well. You can pour it directly into this port where it'll flow out with the drain line and help keep it nice and clean. Now today while we're cleaning out, you can hear I have the vacuum running on it right now. That's pulling everything through. I'm going to go ahead and take a little bit of the sanitizer I used earlier on the inside of the unit. I'm going to pour a little bit of it directly in there and just let that vacuum pull that through. Kind of help break up anything that might be in that drain line. Okay. Make sure everything's still pulling through nice and clean. Alright. The drain line's nice and clear, cleaned out. Shouldn't have any issues there. Now we're going to check out the condenser portion of our air conditioner. Very similar to what we did inside. We're going to be checking the electrical components, make sure all the wiring connections are tight. We're going to test each component, make sure the relays, capacitors, everything's working like it's supposed to. Then we're going to go ahead and check the refrigerant pressures, the amp draws on the motors, and then we're going to give it a nice clean wash of the coil. Make sure it's got plenty of airflow through it so it's working at maximum efficiency. Now as I open this up, obviously the system's only a year old. So everything should be fine. There shouldn't be any issues with burnt, melted wires or damaged components. But one of the most common service repairs that we have around here is capacitors. Capacitors are designed to absorb voltage. So anytime we have thunderstorms or in the spring and with heat pumps, even in the fall, when you're under a heavy workload, a lot of times you'll get capacitors short and failure. And in most instances, it's not something that happened immediately. It's something that's been going on for a while. Capacitors slowly draining and becoming weak. And because there was no maintenance to catch it or realize that was going on, the system will still run until eventually it gets to a point that that capacitor fails and now the system won't run and we have to come out for a service call. On our maintenance, part of what we check is to test that capacitor, make sure that it's reading exactly what it's supposed to, and if not, change it preemptively to save you the payment of that visit on the service call. Occasionally you get one of these little guys in here who had a bad day. And while we're fortunate now in this case, he didn't short anything out. I have had where frogs, lizards, insects sometimes will get in there and they'll short out from one side to the other of the contactor. Wow. And that will cause a problem. That can damage parts as well as trip a main breaker. Okay, both compressor and fan motor amp draws are well within the normal range of what they should be reading. Now we're going to check the refrigerant pressures. We're checking both the low and the high side of the refrigerant system. Our a common mistake that people make, I've seen done on maintenance as well as with service repair calls, just checking the pressure on one side or the other, or checking the pressures together alone doesn't tell you all the information you need to know to determine if the system is operating correctly. Depending on the type of metering device used in the system and the type of refrigerant used, there's also a number we call either a superheat or subcool, which is the difference in the temperature of the refrigerant versus the pressure on the line, and that determines whether or not that system is operating normally. In this case, we're using R410 refrigerant, which uses a TXV for this system, and with that TXV, which is a thermostatic expansion valve, we're going to look for the subcool of the temperature of the liquid line here, which is going to determine whether or not the refrigerant pressure is good and within the range it should be.